Hello everyone, and welcome to our additional mathematics class. I am very happy to see you all here today. Please take your seats, get out your notebooks, and make sure you have your pens ready. Today is going to be a very important lesson. We are going to learn about something called the binomial theorem. Now, I know that name sounds a bit scary, and I know that some of you might feel a little worried about mathematics, but I want you to take a deep breath and relax. We're going to take this step by step very slowly, and I promise that by the end of this lesson, you will understand exactly what is happening. We are not going to rush. We are going to build this knowledge together, brick by brick. So let us start with the very basics. The topic for today is binomial theorem and binomial expansion. Before we can expand anything, we need to know what we are expanding. So what is a binomial? The word itself gives us a clue. Bio means two. Like a bicycle has two wheels, nomial refers to terms. So a binomial is simply an algebraic expression that has exactly two terms. These two terms are connected by either a plus sign or a minus sign. Let me give you some examples so you can see what I mean. If I write x plus 3, that is a binomial. Why? Because there are two parts. There is an x and there is a 3, and they are joined by a plus. Another example is 2a minus b. Again, two terms joined by a minus. Another one is 5x plus 4y. Two terms plus sign. And one more, 2x minus 3. Two terms minus sign. These are all binomials. Now, let us look at things that are not binomials. This is just as important. If I write x plus y plus z, is that a binomial? No. Count the terms. There is x, there is y, and there is z. That is three terms. We call that a trinomial. What if I just write 5x? Is that a binomial? No, that is only one term. We call that a monomial. So remember the rule. A binomial must have exactly two terms. Now, what do we mean by binomial expansion? Imagine you have a binomial, like x plus 2, and you put it inside brackets. Then you put a small number outside the bracket, like a power. For example, x plus 2 to the power of 2. This means we need to multiply it out. We need to open up the brackets. This process of multiplying it out to get a long string of terms is called expansion. When we see x plus 2 to the power of 2, it actually means x plus 2 multiplied by x plus 2. When we see x plus 1 to the power of 3, it means x plus 1 multiplied by x plus 1 multiplied by x plus 1. Our job is to multiply these brackets together until there are no brackets left. Let us try doing this manually for small powers. This is our first method, called expansion by repeated multiplication. We will look at example 1. The question is, expand x plus 2 squared. Step 1 is to write it as multiplication. So instead of writing the power of 2, we write two brackets. Open bracket x plus 2, close bracket. Multiplied by open bracket x plus 2, close bracket. Step 2 is to multiply each term. Many of you might have heard of the FOIL method. F stands for first, O stands for outer, I stands for inner, L stands for last. Let us apply that here. First, we multiply the first x by the second x. That gives us x squared. Outer, we multiply the first x by the positive 2. That gives us positive 2x. Inner, we multiply the positive 2 by the second x. That gives us another positive 2x. Last, we multiply the positive 2 by the positive 2. 2 times 2 is 4. So that gives us positive 4. Now we write all that down. X squared plus 2x plus 2x plus 4. Step 3 is to collect like terms. Look at the middle parts. We have positive 2x and another positive 2x. If you have 2 apples and you get 2 more apples, you have 4 apples. So 2x plus 2x equals 4x. So our final answer is x squared plus 4x plus 4. Please write that down in your notes. Let us try a slightly harder one. Example 2. Expand x plus 1 cube. Cubed means to the power of 3. So step 1 is to write it as repeated multiplication. We need 3 brackets. Open bracket x plus 1 close bracket times open bracket x plus 1 close bracket times open bracket x plus 1 close bracket. Step 2, we cannot multiply 3 brackets at once easily. So we expand the first 2 brackets first. We just did something similar before. X plus 1 times x plus 1, x times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. So, x squared plus x plus x plus 1. Collecting the like terms, x plus x is 2x. So the first part becomes x squared plus 2x plus 1. Step 3, we must multiply this result by the third bracket. So we have open bracket x squared plus 2x plus 1 close bracket multiplied by open bracket x plus 1 close bracket. This looks long, but let us take it term by term. First, take the x squared from the first bracket and multiply it by the second bracket. X squared times x is x cubed. X squared times 1 is x squared. Next, take the 2x from the first bracket and multiply it by the second bracket. 2x times x is 2x squared. 2x times 1 is 2x. Finally, take the 1 from the first bracket and multiply it by the second bracket. 1 times x is x. 1 times 1 is 1. Now, let us list everything we got. X cubed plus x squared plus 2x squared plus 2x plus x plus 1. Step 4. Collect like terms. Look at the x squared terms. We have 1x squared and 2x squared. That makes 3x squared. Look at the x terms. We have 2x and 1x. That makes 3x. So the final answer is x cubed plus 3x squared plus 3x plus 1. Now, I want you to look at the numbers in front of the x terms. These are called coefficients. In our answer, the coefficients are 1, 3. 3, 1. Where did these numbers come from? They did not come from nowhere. They come from a special number pattern called Pascal's triangle. This leads us to our next section. Sometimes multiplying brackets takes too long, especially if the power is large. Imagine if you had to multiply 10 brackets together. That would take forever. So, a mathematician named Blaise Pascal found a shortcut. He created a triangle of numbers that gives us the coefficients directly. Let us describe Pascal's triangle. Imagine a triangle shape. At the very top, there is a single number 1. We call this row 0. Below that, there are 2 numbers, 1 and 1. This is row 1. Below that, there are 3 numbers, 1, 2, 1. This is row 2. Below that, there are 4 numbers, 1, 3, 3, 1. This is row 3. Notice, this matches our previous example. Below that, row 4 has 1, 4, 6, 4, 1. Below that, row 5 has 1, 5, 10, 10, 5, 1. You might ask, how do we get these numbers? The rule is simple. Each number is the sum of the 2 numbers directly above it. For example, in row 2, the middle number is 2. It comes from adding the 1 and the 1 above it. In row 3, the first 3 comes from adding 1 and 2 from the row above. The second 3 comes from adding 2 and 1. The edges are always 1. So, how do we use this? Let us say we want to expand x plus y to the power of 4. First, we look at row 4 in Pascal's triangle. The coefficients are 1, 4, 6, 4, 1. Second, we attach powers to the variables. For the first variable, x, we start with the highest power, which is 4, and count down to 0. For the second variable, y, we start with 0 and count up to 4. So the first term is 1 times x to the power of 4 times y to the power of 0. The second term is 4 times x to the power of 3 times y to the power of 1. The third term is 6 times x to the power of 2 times y to the power of 2. The fourth term is 4 times x to the power of 1 times y to the power of 3. The fifth term is 1 times x to the power of 0 times y to the power of 4. Now we simplify. Anything to the power of 0 is just 1. So x to the power of 0 disappears, and y to the power of 0 disappears. So we get x to the power of 4 plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the power of 4. See how much faster that was than multiplying brackets? However, what if the power is very large, like 10 or 20? Drawing Pascal's triangle that big is difficult. So we use a formula involving factorials and combinations. This is section 5 of our lesson. First, let us understand factorials. In mathematics, we use an exclamation mark to show a factorial. It looks like this, n exclamation mark. The factorial of a number means you multiply that number by every whole number less than it all the way down to 1. For example, 5 factorial means 5 times 4 times 3 times 2 times 1. Let us calculate that. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So 5 factorial equals 120. 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12. 12 times 2 is 24. So 4 factorial is 24. There is one very important rule you must memorize. 0 factorial equals 1. It does not equal 0. It equals 1. Please write that down clearly. 0 factorial is 1. Now, let us look at combinations. This is written as n choose r. Sometimes you see it with brackets, like n over r inside brackets. The formula is n factorial divided by open bracket r factorial times open bracket n minus r close bracket factorial close bracket. Here, n is the total power, and r is the term number. But we start counting r from 0. Let us try an example. Calculate 5 choose 2. Here, n is 5 and r is 2. So we write 5 factorial divided by open bracket 2 factorial times open bracket 5 minus 2 close bracket factorial close bracket. 5 minus 2 is 3. So the bottom part is 2 factorial times 3 factorial. Now let us expand the factorials. Top, 5 times 4 times 3 times 2 times 1. Bottom, 2 times 1 multiplied by 3 times 2 times 1. Notice that 3 times 2 times 1 appears on both the top and the bottom. We can cancel them out. So we are left with 5 times 4 on the top and 2 times 1 on the bottom. 5 times 4 is 20. 2 times 1 is 2. 20 divided by 2 is 10. So 5 choose 2 equals 10. This matches the number in Pascal's triangle. Now we are ready for the big formula. Section 6, the binomial theorem general form. For any positive integer n, the expansion of a plus b to the power of n is given by this pattern. N choose 0 times a to the power of n plus n choose 1 times a to the power of n minus 1 times b to the power of 1 plus n choose 2 times a to the power of n minus 2 times b to the power of 2, and so on until we reach n choose n times b to the power of n. There are key patterns to remember here. First, the power of the first letter. A starts high and goes down by 1 each time. Second, the power of the second letter, B, starts low at 0 and goes up by 1 each time. Third, if you add the powers of A and B in any term, they always add up to n. Fourth, If there is a minus sign in the bracket, like a minus b, then the signs of the terms will alternate. Plus, minus, and so on. Let us apply this to a worked example in the style of WA We See exams. Example 3, expand 2x minus 3 cubed. Step 1, identify a, b, and n. A is the first term, so a equals 2x. B is the second term. Be careful here, because there is a minus sign. B equals negative 3. You must keep the negative sign with the number. N is the power outside, so n equals 3. Step 2, write the pattern using Pascal's row 3. The coefficients are 1, 3, 3, 1. So we write 1 times open bracket 2x, close bracket cubed, plus 3 times open bracket 2x, close bracket squared, times open bracket negative 3 close bracket to the power of 1, plus 3 times open bracket 2x close bracket to the power of 1, times open bracket negative 3 close bracket squared, plus 1 times open bracket negative 3 close bracket cubed. Step 3. Simplify each term carefully. Term 1, 1 times 2x cubed. 2 cubed is 8, so this is 8x cubed. Term 2, 3 times 4x squared times negative 3. 3 times 4 is 12. 1 times negative 3 is negative 36. So this is negative 36x squared. Term 3, 3 times 2x times 9. Negative 3 squared is positive 9. 3 times 2 is 6. 6 times 9 is 54. So this is positive 54x. Term 4, 1 times negative 3 cubed. Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. So this is negative 27. Final answer, 8x cubed minus 36x squared plus 54x minus 27. Please check your signs. Did you get the minuses in the right place? Now, sometimes we do not need to expand the whole thing. We just need one specific term. Example 4. Find the fourth term of x plus 2 to the power of 6. We use the general term formula. The formula says the term number r plus 1 equals n choose r times a to the power of n minus r times b to the power of r. Step 1. Identify values. N is 6. We want the fourth term. The formula uses r plus 1. So if r plus 1 equals 4, then r must be 3. A is x, b is 2. Step 2. Substitute into the formula. T4 equals 6. Choose 3 times x to the power of 6 minus 3 times 2 to the power of 3. Step 3. Calculate 6, choose 3. This is 6 factorial divided by 3 factorial times 3 factorial. 6 times 5 times 4 divided by 3 times 2 times 1. 3 times 2 times 1 is 6. So the 6 on top cancels with the 6 on the bottom. We are left with 5 times 4, which is 20. Step 4. Finish the calculation. We have 20 times x cubed times 2 cubed. 2 cubed is 8. 20 times 8 is 160. So the fourth term is 160x cubed. Now let us look at some special cases. Section 8. First, the middle term. If the power n is an even number, there is only one middle term. The position is n divided by 2 plus 1. For example, in x plus 1 to the power of 6, n is 6. 6 is even. So the middle term is the fourth term. If n is odd, there are 2 middle terms. Second, the term independent of x. This is also called the constant term. This is the term where the x disappears completely. This happens when the power of x becomes 0. Example, find the constant term in open bracket x plus 2 over x close bracket to the power of 6. Step 1. Write the general term. Tr plus 1 equals 6. Choose r times x to the power of 6 minus r times open bracket 2 over x close bracket to the power of r. Step 2. Group the x terms. 2 over x to the power of r is the same as 2 to the power of r times x to the power of negative r. So combining the x parts, we have x to the power of 6 minus r times x to the power of negative r. When you multiply powers with the same base, you add the exponents. So 6 minus r plus negative r equals 6 minus 2r. Step 3. Set the power of x to 0. We want the constant term, so the power of x must be 0. 6 minus 2r equals 0. Add 2r to both sides. 6 equals 2r. Divide by 2. r equals 3. Step 4. Calculate the term using r equals 3. We need 6 choose 3 times 2 to the power of 3. We already know 6 choose 3 is 20. 2 to the power of 3 is 8. 20 times 8 is 160. So the constant term is 160. Now, before we finish, I want to warn you about common mistakes to avoid. Section 9. First, negative signs. When you have a minus in the bracket, like a minus b, many students forget to put the negative sign on b in every term. Remember, b is negative. So when you square it, it becomes positive. When you cube it, it stays negative. Write brackets around negative numbers to help you, like open bracket, -3 close bracket squared. Second, confusing n and r. Remember, n is the big power outside the bracket. R starts at 0 for the first term. So the first term is r equals 0. The second term is r equals 1. Third, factorial errors. Remember, 0 factorial is 1, not 0. Fourth, term numbering. If the question asks for the fourth term, r is 3, not 4, because the formula is tr plus 1/5 power rules. When you simplify open bracket 2x close bracket cubed, you must cube the 2 as well. 2 cubed is 8. Do not just write 2x cubed. That is wrong. Now it is time for class evaluation. Section 10. I want you to solve the following in your notebook. Do not rush. Question 1. Expand x plus y to the power of 4 using Pascal's triangle. Question 2. Calculate the value of 7 choose 2. Question 3. Find the first 3 terms in the expansion of 1 plus 2x to the power of 5. Question 4. In the expansion of open bracket x minus 1 over x close bracket to the power of 4. Find the term independent of x. Take your time with these. I will walk around the class to check your work. For your homework assignment, section 11, please complete the following at home. Question 1. Expand 3x minus 2 cubed fully. Question 2. Find the coefficient of x squared in the expansion of 2 plus x to the power of 6. Question 3. Write down the 5th row of Pascal's triangle. Question 4. If n factorial equals 120, what is the value of n? Make sure you show all your steps. Do not just write the answer. Finally, let us do a summary of what we learned today. Section 12. A binomial is a two-term expression. Pascal's triangle provides coefficients for small powers. The binomial theorem is the formula for expanding any power n. The general term formula allows us to find specific terms without full expansion. And remember, alternating signs occur if the binomial has a subtraction. I know this was a lot of information. Mathematics can feel heavy sometimes, but you have done very well today. You learned how to expand brackets, how to use Pascal's triangle, how to calculate factorials, and how to use the big binomial theorem formula. These are tools you will use for a long time in your mathematics journey. If you're still confused about any part, please come and see me after class. Do not be shy. It is better to ask now than to be confused later. Practice is the key. The more you practice the factorial cancellation and the sign changes, the easier it will become. Thank you for your attention today. Please pack up your things neatly. I will collect your evaluation questions before you leave. Have a wonderful day, and I will see you in the next lesson. Remember, mathematics is not about being perfect immediately. It is about understanding the process. You understood the process today. That is a victory. Keep your notes safe, review them tonight, and try the assignment tomorrow when your mind is fresh. All right, class dismissed. Thank you. Wait, before you go, let me just re-emphasize one thing about the general term. Many students lose marks here. When you're asked for the fifth term, you must set r plus 1 equals 5, so r equals 4. If you use r equals 5, you will get the sixth term by mistake. Always subtract 1 from the term number to find r. Also, when calculating combinations like 6 choose 3, write out the factorials fully first. 6 times 5 times 4 times 3 times 2 times 1. Then write the bottom ones. Then cancel. Do not try to do it all in your head. Write it down. Writing it down prevents silly mistakes. And one last thing on the constant term. When you have x in the denominator, like 1 over x, treat it as x to the power of negative 1. This makes the algebra much easier. So 2 over x is 2 times x to the power of negative 1. When you raise that to the power of r, the x becomes x to the power of negative r. Then you add the exponents. This is the secret to finding the constant term quickly. Okay? Now you can go. Goodbye, everyone.